This is an excerpt from a recent Power Up webinar examining how fast is fast, measuring computer system performance. Hi, my name is Larry Jordan. In this short illustrated video tutorial, I explain what computer RAIDs are and the differences in speed, capacity, and data protection between the different RAID types. Kristen writes, would you explain RAID systems and how those differ from an external drive or backups? I'm considering investing in one, which is a really smart decision. If we start by defining terms, an external drive is any storage, even a single drive, that's located outside the computer case. A RAID is a collection of drives that appear and act like a single drive. A backup is a copy of selected files generally stored on a separate device. In other words, most RAIDs are external, but not all external drives are RAIDs. In fact, there's two types of RAIDs. There's a hard disk drive RAID and a solid-state drive RAID. An HDD, for hard disk drive, HDD RAID, contains 4 to 16 spinning hard disks. These provide vast capacity, medium speed, and significant latency. Latency is the time it takes to get data off the drive. A solid-state drive is a single drive like the Samsung T7 that delivers extreme speed with limited storage capacity and zero latency. There's no delay getting media from a solid-state drive, and there's two types, PCIe and NVMe. PCIe is medium fast, and NVMe is extremely fast. An SSD, solid-state drive RAID, is composed of, generally, 4 solid-state drives, which provide medium capacity, extreme speed, and zero latency. For instance, there are 6 RAID types, RAID 0, 1, 4, 5, 6, and 10. RAID 0 stores data across all drives. There's no data redundancy. If you lose one drive, all the data stored across all drives is lost. Now, this doesn't store one file to one drive. It divides the file up into pieces and stores the pieces on all 4 of the drives. The reason this helps is now I can use the speed of all 4 of those drives, combine them to make reads and writes faster, and I can combine the storage capacity of all those drives to provide a lot more storage capacity than a single drive alone. When we calculate the speed of a RAID 0, it's the speed of one drive times the number of drives. So let's assume, because the math is easy, that a drive transfers data at 200 megabytes a second. We multiply that times the number of drives, 4, and that means that the RAID will deliver 800 megabytes per second of data transfer, both reading and writing. The capacity of a RAID 0 is equal to the capacity of one drive times the number of drives. For example, let's assume each of the drives is 4 terabytes times 4 drives. That gives us 16 terabytes of storage. The good thing about RAID 0 is extremely fast and holds a lot. The bad thing is if you lose a drive, you've lost all your data. So the exact opposite of RAID 0 is RAID 1. This only uses 2 drives. The data is stored on one drive, and it's then copied in its entirety to a second drive. Provides complete data redundancy. If one drive dies, all your data is safe on the other drive. But it's not very fast. The speed of RAID 1 is equal to the speed of a single drive. For example, 200 megabytes for a 2-drive system. And the capacity is equal to the capacity of one drive, 4 terabytes in this case. You can only have 2 drives in a RAID 1. If I have 3, 4, or 5 drives, all I'm doing is making multiple copies of the same data. You essentially end up with 3 drives that have the exact same data on it. There's no big advantage to having a RAID 1 that has more than 2 drives. Well, we want both data redundancy, protection for our data, and we want more speed. So a new format of RAID was invented called RAID 4. Here, the data is stored across 3 drives with the 4th drive reserved for parity data. If we lose one drive, all the data is safe because it can be reconstructed from all the drives that are left. RAID 4 is optimized for SSD RAIDs. It's the way the SSD reads the data makes this an optimal form. The speed is calculated as the speed of one drive times the number of drives minus 1. Gives us 200 megabytes a second. 4 drives minus 1 is 3, is 600 megabytes per second of data transfer speed. The capacity is equal to the capacity of one drive times the number of drives minus 1. 12 terabytes in our example. While RAID 4 is optimized for SSD, RAID 5 is optimized for spinning media, HDD hard drives. Here, the data is stored across all 4 drives, but a portion of each drive is reserved for parity data. If we lose one drive, it doesn't make a difference which one. We lose any single drive, all of our data is safe. RAID 5 is optimized for spinning media, HDD RAIDs, and the speed is calculated the same way as it is for RAID 4, the speed of one drive times the number of drives minus 1, and the capacity of one drive times the number of drives minus 1 gives 600 megabytes a second and 12 terabytes of capacity in my example. RAID 6 is for the truly paranoid. Here, data is stored across all 4 drives, but each drive holds 2 sets of parity data. We can lose 1 or 2 drives at the same time, and all our data is safe. This is designed or optimized specifically for HDD RAIDs. There's no advantage to using RAID 6 with an SSD RAID environment. The speed is calculated as the speed of one drive times the number of drives minus 2, as is also capacity. 400 megabytes a second and 8 terabytes in my example. Another form of RAID was invented called a RAID 10 or RAID 1 plus 0. Here, the number of RAIDs, the physical objects inside the RAID container, is divided into 2 equal groups. They have to be equal. Group 1 is formatted as RAID 0 and stores the data. Group 2 is also formatted as RAID 0 and stores a copy of all the data, and the 2 groups are combined as a RAID 1. This gives us the speed of RAID 0 with the data redundancy of RAID 1, but doesn't give us the best possible speed, not as much as RAID 0, but it does give us redundancy. We calculate the speed as the speed of one drive times the number of drives divided by 2. In our example, 400 megabytes a second. And the capacity is equal to the capacity of one drive times the number of drives divided by 2. 8 terabytes in my example. This was an excerpt of a recent Power Up webinar called How Fast is Fast? Measuring Computer System Performance. For the complete version of this online training, please visit my store at larryjordan.com/store and look for Webinar 355. By the way, when you need to stretch your training dollars, membership in our video training library saves you money and time. You can access all our videos for a low monthly price of only $19.99. That's almost 2,000 movies, hundreds of hours on a wide variety of subjects. Plus, premium members can download practice media and projects. Our training covers Apple and Adobe software. We update it multiple times each month, and for more information, visit larryjordan.com/membership. And thanks.